Hi. We're going to compute the windowed average of a list of numbers. Now, normally, this is a very simple thing to do in APL. So let's say we have the numbers 1, 2, 3, 4, 5, 6, and we want to do a windowed average. The specification here says how many neighbors on each side of an element. So let's say we want 2 neighbors on each side. That would mean, like, for the number 3 here, we want these 2 neighbors and these 2 neighbors to be included. So that means these 5. So if we write this as a tacit function, a point-free function, and we have a left argument of 2, which is the window size, but specified as number of neighbors, then the full window size is going to be 2 times this, because it's on both sides, plus 1, because of that middle element. That's the one we're computing the windowed average on right now. So we want the left argument, and we want 2 times that, and then we want to add 1. So this gives us 5. And this is going to be the left argument to the plus reduction. So this doesn't just reduce the whole thing, but rather reduces over windows of that size. So the right argument to the reduction, the actual data that we're going to reduce, is going to be the right argument to this outer function, and the left argument is going to be this expression that is in terms of the left argument. So now we got the sum of 1, 2, 3, 4, 5. So we can see 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, and then 20, because we got 2 plus 3 is 5, plus 4 is 9, plus 5 is 14, plus 6 is 20. Okay, now we just need to find the average. This is the sum. We need to divide by the length. But the length, conveniently, that's already there as the left argument to this plus reduction. So if we wrap that in an inner function, and then say we divide by the left argument here. So there are 3 functions here. This is an identity function that returns the right argument. That's this one. Over here, there's a function in terms of the left argument. That's this one. And the middle function takes the results of those 2 outer functions and says that the ny windowed reduction using windows of this size on this data divided by the left argument. So that's the length of that. Okay, makes sense that the average of 1, 2, 3, 4, 5 is 3, and the average of 2, 3, 4, 5, 6 is 4. Now, here's the catch. And that is, we don't want 2 results like this. Notice that we only computed the windowed averages for these 2 elements and not for all the elements, because there aren't enough elements on the left and on the right to create a full window. And so the problem specification says that we are to extend the original data with copies of the last and the first elements on the right and the left sides, respectively. So let's do that. We can always put in the actual formula for the windowed reduction afterwards. So we want the first element over here, and we want to repeat it as many times as stated over here. So we want a reshape, which is cyclic reshape. So this just reshapes the whole thing. This reshapes and drops the trailing elements. But we want to pre-process the right argument with a first, to take just the first element. So we've got this function composition operator, which is pre-process the right argument, and this is the first function. So this reshapes the first element to the length 2. And how would we get reshaping the last element? Well, there isn't, unfortunately, a function to get the last element, but there is a function to reverse. So if we pre-process the right argument to this whole function with a reversal, and reverse this whole thing, that gives us 6, 5, 4, 3, 2, 1. Take the first, that's 6, and then reshape it. And now we can just concatenate together all the pieces that we've got. So we want the original right argument concatenated with this, and that extends with the right number of 6s on the right, so that the actual original 6 becomes the center of a window of length 5. And then we have the left argument reshapes the first, concatenated to this. And now we have the full data that we're supposed to operate on, so we can go in and take our original formula over here and copy it down here. And that gives us our running windowed average with extended neighbors. So we can get rid of all this and give it a name. And now we can apply to F 1, 2, 3, 4, 5, 6. And we can do it with a 1. So this is the average over every element and its adjacent element. So there's an average of 1 because we're extending 1 and 2. That's 1 and a third. And here we've got average over 1, 2, 3. That's 2, and so on. Thank you for watching.